Hello, in this video, we're going to cover chapter 1.2. So this is 1.2 part 1. 1.2 is about classes of function. We would classify function according to the different formula. And in this particular video, we'll look at a few function like linear function, polynomial function, and also application of the linear and quadratic function. So what is a linear function? Linear function has the form of f of x equal to mx plus b, where m is the slope of the function, b is the y-intercept. And from algebra, you should have learned that slope is y2 minus y1 over x2 minus x1 if you have 2 points, x1, y1, and x2, y2. So basically, it's change of y over change of x. It's also known as the rate of change of y per change of x. A linear function, a typical form is f of x equal to mx plus b, but a line can be written in Poinslow form as well as in standard form. So this is how we do a Poinslow form, y minus y1 equal to m, x minus x1, or in standard form, ax plus by equal to c. And in calculus, the slope formula is very important, and also the Poinslow form is also important. In chapter 3, we'll use this quite a bit. Polynomial functions are functions that are in the form of a(n)(xn) plus a(n)(n) minus 1 xn minus 1 plus a1x plus all the way to plus a0, which is a constant. So why is it called a polynomial function? All these exponent of n are integers greater than 0, and each of these an minus 1 are constant. The highest exponent of x is called the degree of the polynomial. And the terms where we have the coefficient of the highest power of x is called the leading coefficient, and this term is called the leading term. So an example of a polynomial function would be this: 2x4 minus 3x to the 3 plus 2x to the square minus x plus 1. So 2x to the 4 is the leading term, and 2 is the leading coefficient. And the degree of this polynomial is degree 4. Okay, so that's how we describe polynomial function. And one of the particular, there are several particular polynomial functions that are very common, and we give them a name. So quadratic function is where the degree is 2, ax squared plus bx plus c, where a is not 0. And, oh, this is supposed to be f. And then there's a cubic function. The highest exponent is 3. So the leading term is ax to the 3. Okay. We can also have something called a power function that overlap with polynomial function, and it is written as f of x equal to a x to the b. That means there's only one term, and that term has x to a particular power. But unlike in polynomial where we limited it as a positive integer, a power function actually allow b to be any real number. So you can have 3x to the 4, which is a polynomial function, as well as a power function, but you can have f of x equal to x to the negative 1, or even f of x equal to 5, x to the 2/3 or 1/3 is also a power function. Okay. So we want to talk about end behavior of polynomial function. We know how the function look like is consists of all the power of x in integer form, integer power of x. But if we graph it, how does it look like? It turns out that polynomial functions has something that is in common in how they ends, or we call it the end behavior. So what is the end behavior? The end behavior is what is y, what does f of x or y look like when x approaches infinity from the positive or the negative side. That means if I graph something, when x is really in the infinity, where would y be? And also when x is in the negative infinity, where would y be? So would y be flattened out or would it go to infinity? If it goes to infinity, is it positive or negative? It turns out that for polynomial function, they never flat out. They are always going to either positive or negative infinity, and that is determined by the leading coefficient an and the degree of the highest degree of the leading term, or the degree of the leading term, or the degree of the polynomial function. So we have this already figured out. So what happened is if we have a polynomial function like the one that we have earlier, 2x to the fourth minus 3x cubed plus 2x squared minus 1. In every polynomial function, the leading term actually determines the end behavior. So if you want to know how does this polynomial functions behave in the end, you do not need to worry about any of these terms. You only look at the leading terms. And if the leading term is positive, but n is even, then you just imagine if x approaches infinity and you have x to the n power which is even, then y would and then an is positive, y would also approach infinity. And on the negative side, when x approach negative infinity, y also approaches infinity because you do a even power of a negative number is going to be positive. Whereas if an is negative, then when x approaches infinity, y would approach negative infinity. And when x approaches negative infinity, y would also approach negative infinity. You can think of this as they goes up on the two sides, and in the second case, y goes down on both positive and negative infinity. What about when n is odd? When n has an odd degree, when x is approach infinity and an is positive, y would also approach positive infinity. But when x approaches negative infinity and you have a odd power, y would approach negative infinity. So x and y goes both positive or negative. So you can think of it going up and going down like this. And inversely, when x approaches infinity, and if we have this is a typo, it's a negative 0, then y would approach negative infinity. They go different direction. X approach negative infinity, y would approach positive infinity. So in terms of the graph, you would see a graph that goes when it is positive x, they go down for y. When it is negative x, then it goes up. Okay, so these are the 4 types of end behavior for all polynomial function. It helps us to graph the function. In order to graph a polynomial function, of course, zeros are very important. To solve for zero of a linear function, that is very easy. It's just a linear function solving. But for quadratic, you can use factoring, you can use square rooting, or you can use quadratic formula. So we went over how we do factoring in chapter 1.1. So we're going to look at how we can find the zeros using factoring as well as quadratic formula here. So let's see, we are going to find the zeros of this and then sketch a graph of this polynomial function. So we were going to try factoring first. We always try to find factoring. 0 means when y is 0. So we're going to solve. So we're going to define zeros. We're going to solve x cubed minus 3x squared minus 10x equal to 0. So you factor the x out first. Minus 3x minus 10 equal to 0. And then we need to factor more of this quadratic term. It turns out that this is factorable. Why? Because you can find two numbers, when they multiply, they are negative 10. And when they add, they are actually negative 3. So negative 3, negative 10. So x minus 5, x plus 2 equal to 0. So, and then we solve it for 0. X is equal to 0, x is equal to 5, and x is equal to negative 2. So we have 3 zeros. So we're going to sketch the graph. We graph those zeros on our x-axis because they are x-intercept, and also 5. So how does it start? What is the end behavior? The end behavior, because this is x cubed and our x1 is 1, so we know it is the types where you have when x goes to infinity, y goes to infinity. When x go to negative infinity, y go to negative infinity. So it goes from here and then we just come back and we go like this. So this is the sketch. Now how high or low does this peak goes? We do not know. And we would be able to do that in chapter 4, I guess, when we learn after we learn calculus. The second one is find the zeros of a quadratic 3x squared minus xx plus 2. So how do I go about doing this? And behavior, well, this is a square, which is an even degree, and I have a positive number, so the end behavior I know is going to be like this, right? It goes up in both positive infinity and negative infinity situation. And we need to find 0. So we solve 3x squared minus 6x plus 2 equal to 0. And this obviously cannot be factored because there's no way you can factor, you can have a x, two number, when they multiply they are 6, but when they add they are negative 6. So it is not factorable. So we have to use the quadratic formula. Quadratic formula is x equal to negative b. So in this case it's 6 plus and minus b squared is 36 minus 4 times 2a, 3 times 2, all over 2a, which is 6. So it becomes 6 plus square root of, so this is 12 over 6. That's around 6 minus square root 12 over 6. If we want exact solution, we should simplify them. But we are not. We are just trying to figure out where that the two number is. So then divided by 6. In your calculator, this is around 1.6. And 6 minus square root of 12 divided by 6. That is 0.4. So we know that we have 2 x-intercept about 1.6 and 0.4, and it's going up. So like that. So that's our sketch. Okay. So maybe I'll use the other video to talk about the application models of linear function and quadratic function.